I'm Rachel Parkin. I'm the Product Development Manager at Smith & Nephew. Smith & Nephew is the company that also made the frame that you saw in the operation earlier. So as a development engineer, I'm a mechanical engineer is my original degree, and I'm responsible for designing a product that gets the idea of the surgeon into an actual physical product that he can use. So the surgeons very often have the ideas, and it's the engineers that then make those ideas work into a product that they can implant in patients. So very often you might have heard of osteoarthritis. That's where the surface of the joint wears out, so the cartilage actually physically wears out. In that case, you would probably need a hip replacement. So this is a hip replacement, and you can see it's made of a stem component. Now that's titanium, that goes down your thigh bone. It has a little ball on it, that's made of ceramic. And on the cup side, the acetabular side that goes in your pelvis, it has a liner of ceramic and a shell of titanium. That's one way of doing a hip replacement. There's another way too, which involves taking less bone out. So you can compare these two products. You see it doesn't take quite as much bone away. Now the difference here is these two products are made of cobalt chrome. Cobalt chrome is a very good bearing material, so it doesn't wear very much. It's very, very hard. The downside to cobalt chrome compared with titanium is that it's not very biologically, the body doesn't like it quite so much. So this particular example has a coating of hydroxyapatite. That's found in your bone, and that helps the body to grow bone cells in and onto that product, hold it in place. So as well as the material side of this product, the engineering technology that goes into this is to make sure that the surfaces, the two products fit together. So when you take two different products out of a box, they'll mate together and fit. So if you imagine that head has to be very, very round, and it's very smooth as well, and similarly on the cup side. So there's manufacturing engineers and quality engineers inspecting these to make sure that every product is to our specifications. If, for example, this wasn't a perfect sphere, you would get a lock. So the joint physically wouldn't move, and you wouldn't be able to bend your leg. If you tried to bend your leg, you might actually pull the product out of your hip, out of the bone fixation. Okay, so if we take the head component, the ball, so I've got a mock-up here of what the steps the surgeon might go through. So the first part of this is to make sure that he gets the right alignment through the femoral head. So imagine this is your diseased hip joint. So he puts a pin through it. Now that acts as a guide for the next step. He then takes a drill and drills to enlarge the hole. After that, we put a guide bar in place. So that helps us to centralise all the other tools, so we've got the product exactly where we want. A scrub nurse would pass the surgeon all the tools ready to go. He then places the cutter over the guide bar and reams away the bone. So what we're doing is creating the geometry of the bone to match the inside of the head component. The next step is then another cutter, plan cutter, which again goes over the guide bar to make that flat cut. And finally, the same guide bar is in place, and you use a chamfer cutter just to put a chamfer on the bone. So then the surgeon's then ready to put the head onto the prepared bone. So once the head is in place in the bone, the surgeon would have already prepared the cup side of it and pushed a metal cup again into the bone. So that's held in place just by the bone gripping that tightly and a push fit. And then would put the leg back in the correct position and stitch up the operation scar. So that makes an enormous difference to people's lives. People of all ages, from 14 up to 80-year-olds, have had this type of operation. And indeed, some people do marathons with this kind of joint, and you wouldn't know that they've had a hip replacement.